We're now going to look a little bit more at graphing. First thing we're going to look at are special cases of horizontal and vertical lines. You need to know the difference. Remember, with horizontal, slope is 0. Okay, vertical lines, slope is undefined. So in this one, anytime you have an f of x, which is a y, you'll always have a numerical slope. And this is about the third time maybe that we've seen this. But with x not being here, that means my slope is 0. So this is a horizontal line through a y value of -3. So let me go get me my lines. Let me get it -3. And that would be my graph of that particular equation. So 0 slope, horizontal line, and this tells me the y-intercept, remember, and that's where the line hits the y-axis. Now, x equals 5. You do not have this on your y equals calculator. It will not graph it. So you have to remember x equals 5 is a linear equation, but it has a slope that's undefined, and the only way it can be undefined is if it's vertical. So for this particular one, I am going to 1, 2, 3, 4, 5. It's a vertical line through x equals 5. Now I usually have some students that get these two confused, and I try and use something that looks familiar or should be familiar, and that's your alphabet. If you'll notice, it's the last 6 letters of your alphabet. There's a little squiggle in between so you can, keep them separate. But the U is for undefined, V is vertical, and it's with x equations. Undefined, vertical, with x equations. Y equations are horizontal, slope is 0. So if you can remember your last 6 letters of the alphabet, but know what those particular letters represent, it might help you get these correct. Okay? Now the other type of graphing we're going to look at is x and y intercepts. If the equation is in the form of ax plus by equals c, then first thing you do is make a table. Second thing you do is find your intercepts. This is called the intercept method. So if I let x be 0, that means this term will drop out, and I have a very small equation to solve. Notice it says substitute 0 in for x into the equation to find the y value. Then you turn right around and let y be 0. Substitute 0 in for y into the equation to find the x value. I've got 2 examples here. Notice it's in the correct form where x and y are on one side, constants on the other. So if I put 0 in for x, this term just disappears. You got 5y equals 10, so y should be 2. Now I turn around and let y be 0, so this is not there, because if you substitute in 0, that term drops. Divide both sides by -2, x equals -5. Now, let's see if I can get a point real quick. So I need 0, 2. That's a big point. It's not going to let me make it any smaller, I don't think. Ah, yes it did. Alright, so now I'm going to move it right here to 0, 2. And I need it solid. Oh, Pooh Bear. There we go. Then I need it on -5, 0. So let me get on -5, 0. And now I connect my points. Let's see how good I can do this. Oh well. It's a whole lot easier if you do it by hand. Now we move it up this way. I've almost got it. Okay. It's very, it's real quick if it's in this form. Now, I do have some students who like to solve it for y, but by the time you solve it for y, you could have it graphed. Let's try this one. If I let x be 0, I'm going to have to divide both sides by 4, so that would be 6/4, which is 3/2, or 1.5. And if I let y be 0, x will be 2. And then I do the same thing. Let me see if I can... No, it's not going to let me get my points. Pooh Bear. Oh, well, I'll go make another point. Let me see, I need 0, 1.5. I think it automatically makes a monster one. Okay, so let me make that go down. Come on, point. Okay, let me make that solid. Now I need it on 2, 0. So 2, 0. Okay, well, let's see if I can connect them a little bit faster this time. Line is not cooperating. That's not too bad. But that's graphing using intercepts. So if any time it's in where x and y are on the same side and constant on the other, it's real quick doing the intercept method. The other thing you could fall back on is solve for y, but I do have students make mistakes with signs. So it, again, is up to you. Thank you.